Hi, welcome to Chapter 7. This is going to be a very short chapter, and I like to keep it that way since basically this will give you some time to work on the midterm. That midterm program that you basically is due probably this week or next. So anyways, this chapter is a very important chapter because what it allows us to do is allows us to make sure that any input that we get from the user will basically be validated before we can basically use it in any type of processing. For example, if I'm expecting a numeric data and let's say my user types in a $sign and a comma, well, that's basically not numeric, so it's going to cause that program to basically, that part of the program to basically blow up. So this, again, it's a very short chapter but very important chapter because it allows us to make sure we validate our data coming in and making sure that it's basically going to be utilized by the program. So the very first thing this talks about is, and you'll hear this a lot in the programming world, is garbage in, garbage out, meaning if you put garbage into a program, you're going to get nothing but garbage out. And so again, it says if a program reads bad data as input, it will produce bad data as output. Programs should be designed to reject bad data that's given as input, and that's, again, the whole purpose of this program. So let's just go ahead and take a look at Chapter 7.1, and so basically here's what it does. We have a real hours, pay rate, and gross pay, and we have entered the number of hours worked, and we get those from the user, and then we have a loop. Again, this is a until loop. We basically do it until it becomes true. We're checking to see is number pay rate, okay? And so what is number? It's basically a built-in function by the let's just so it is a built-in function that's built into Raptor. And again, if it is a number, if that's no, we're going to come back around and ask for that again. We're going to keep asking for that until we get an actual valid number, and then we'll go into the gross pay is equal to hours times pay rate. We go ahead and set it to 2 decimal places, and we say that the gross pay is $ gross pay. So very, very easy. Let's basically go ahead and run it. So I'm going to type in 1, 005.33. We'll click OK, and notice that it basically came back around. Now we should have said something to the effect of that was invalid, type in a better one. So I'll type in 12.75 now, and it comes in and says I don't know what happened there. Oh, number of hours worked. My bad. I screwed up. So let's run it again. It's going to ask for hours worked first. Well, they worked 40 hours, and their pay rate is 1,005.33 an hour. And notice it comes right back and says enter the pay rate. Okay, and so again, it'll keep doing that until we type in a valid number. Now we really should have some type of a that's where I'll put 12.75, and then it comes up and says your gross pay is $510. Now we really should have done this. We really should have had some kind of an output right here that says, please re-enter a valid numeric value. Okay. And what that does for us is that, because if I run this way, I'll type in 40 hours, I type in 12.75, it works just fine. It gives us exactly what we want over here is $510. But again, if I type in an invalid, so I type in 40 hours and 1,005, it comes and says, please re-enter the valid numeric value. It comes back up. Okay. Now we could have done this a couple of different ways, but again, we just don't want to keep asking the user for a pay rate, because they'll go, I just entered that, and they'll re-enter the same value, and they'll keep entering the same value and keep entering the same value because we're not telling them anything. So again, it's very important we also, not only do we validate the data, but if they type an invalid data, we have to let the user know that it's invalid. Okay. So again, very simple. We're just validating any input we get from the user. If we're expecting numeric, make sure it's numeric. If we're expecting some type of a string parameter, or we're expecting some type of specialized data, maybe it's all uppercase, we're expecting all uppercase, and we need to be able to check for that as well. So the validation loop, that's basically what we had just gone through, is, again, it's a pretest loop, meaning that if it's basically, in our case, false, it's going to slip right through. We won't even know that basically there was an error. So we get the input, we check to see if the input's valid. If it's invalid, we go ahead and display the error message. We get the input again, we come around. Now this is probably the best way to do it. We get this input once and we fall through. But if we don't get it, that's where we display a new input message. Okay, and so so here it is. While the score is less than 0, we're going to display an error. The score cannot be less than 0. Display enter the correct score and then put the score, and we end the loop. So would there be a way for us to do that? Now here's another one. While the score is less than 0 or greater than 100, we're expecting something between 0 and 100. If they type anything less than 0 or over 100, that's going to basically make this invalid. So what could we have done over here to basically do that differently? Well, we could have done this. I could have taken this guy and put it before the loop. Okay, and then I'll get rid of this output. I'm going to put an input loop right here that says, please re-enter valid numeric values. And that's when we're going to ask for the pay rate. Okay. So now this is going to work a little better, because now I run this, I type in my hours, I type in my hourly pay, I want to type 1,005, I hit the enter key, and it says please re-enter a valid numeric value. Okay, so I type in 12.75 now, and there it goes. I could have also said, hey, that was an error. I could have done this where I said, I could have had error. We'll put a valid numeric value, not values. That sounds a little better. So again, 40 hours, 1,005. And it says error, please re-enter a valid numeric value. So now the user knows they had an error, and it's telling them please re-enter a valid numeric value. So basically the user now knows what they entered is not a numeric value. Okay. So here's in the spotlight. In Chapter 5, you saw a program that your friend Samantha used to calculate the retail price of an item in her import business. Okay, we can go back to chapter 5 and look at that. Samantha has encountered a problem when using the program, however, when some of the items that she sells have a wholesale cost of 50 cents, which she enters into the program as 0.50. Because the 0 key is next to the negative key, she sometimes accidentally enters a negative number. She's asked you to revise the program to basically validate the input. So we take a look at 7.2, and let's quick go back and look at 5.6. Yeah. So this is the one where we basically take the wholesale cost times 2.5 to get the retail price. Yeah. So, okay, so we take a look at this program again. And here we've got show retail. And there we are. Whoop. We just calling show retail? Okay. Huh. I can't see where. It's just a subchart. Ah. Okay, hold on. Apparently I created this a long time ago, and I added this as a subchart. I actually changed it now that it's a procedure. So, so let me get back up to. So here's what the main does. Well, let me fix this. I'm going to change that to underscore retail. Okay. So here's how it works. We set this. It's kind of like a sentinel value, do another equals no, and then we go into our until loop, and we basically, first thing we do, so it's basically a do until loop. So we go into show retail. So show retail basically sets a wholesale price, a retail price, and a markup, which is a constant of 2.5. We go to the item's wholesale number, and we say if wholesale is greater than 0, the cost cannot be negative, please enter a correct wholesale cost, and we get the wholesale cost again. So basically we're going to loop this until we get a positive number. And then once we get that, so really the only thing we change between the 5.6 and this one is we just added this loop that basically says we have to make sure that it's a valid. Now we could have also put in and is number wholesale. Okay, so we could have done that as well to make sure that we do have a valid numeric value and it's above 0. Okay, so we run this. So now it's asking for a wholesale price. I'm going to accidentally use the negative sign. So 3.56, hit that, and it comes through and says I treated it as a string. Ha ha ha. So let's do this again. Can't compare these values, string and number kind. Aha. Okay. So apparently I can't do is number because that's a string value. This is where Raptor gets kind of squirrely. Is numeric is a string comparison, and this wholesale greater than 0 is a numeric comparison, and you can't blend the two together. So what I would have to do is this. Probably have to put another loop inside of here, or a decision check that says, so yeah, I could just do a decision. Yeah, I could put a decision right here that basically says, is number wholesale if it is, we're just going to go on in. If it's not, this would be a cheap way to do it, but I'm going to do this. I'm going to say wholesale is equal to -1. Now, why am I doing that? That's so it will basically, this loop will catch it and then basically ask them to enter a numeric value again. So again, kind of a cheap way to do it. It'll work, but yeah. So let's see if that works. So I'm going to do the 3 minus 2, 3. Okay. Cost cannot be negative, or maybe we need to change that to say can't be negative, or must be a numeric value as well, something to that effect, and please re-enter. So we'll say 2.36, and it comes up and says, do you want to do another? I'm going to say no. And the retail price is 5.90. Okay, so again, when we get to these different types of checks, again, Raptor is kind of squirrely. It's a great program. It really truly is a great learning program. It would also be a great program to use for documentation for your production programming languages that you use. Again, it's a great way to work out your logic. It's a great way to get things kind of laid out. And then basically, again, what's great about this is really you don't have to have a programming knowledge. You just have to have a logical brain. So as a business analyst, they could lay out this particular logic, or even a systems analyst where they basically kind of they kind of design the systems, and then they kind of lay things out, and then they pass those on to the actual programmer to basically write the program. So again, this is a great program to do that, but it does have its drawbacks, and this is one of those. So again, kind of a cheap way to do this, but it works. It works in the sense that it will basically get the same results. Okay. So again, the whole point of this chapter is validating the input from our user. So we could have validated with a post-test loop, meaning basically a do until, where we actually do it once and then basically check at the end of the loop. We could have wrote a function, a validating function, to validate this particular item. So we could have actually had it call. Again, we can't do functions in Raptor, but if we in a real world situation, we could have actually called a function to validate that particular input, and then come back. And let that function deal with the user as far as if they did it wrong, get the so really when we come back from that function, we will have valid data. Okay, and that's the whole point of that function, is we get the input from the user, and then we call that function to validate it, and whatever we get back from that function will be valid data, because we'll let that function. And what's great about that is, as a programmer, I can write the program and somebody else can write that validation process. Okay, so we can have another team that does nothing but validation. So that's another good thing about sub-procedures, is I don't write the whole thing. I write my piece, they write their piece, and we put them together. Or they may write a piece, they may have a validation piece that's already written. I can actually go call it. So that's the great thing about programs, especially when they're modularized and have functions, is we can actually then just go out and call that particular function that's not even part of my program. Okay. Again, validating string input, no difference. We can validate it. So like here we say, while the answer is not equal yes and answer is not equal no, display, please answer yes or no. Your supervisor, okay, effective leader, answer input. Is your supervisor an effective leader? Input answer. If answer not equal yes and answer not equal no. So basically we want a yes or no answer. If they type anything else but yes or no, then we're going to basically ask them to input it again. Okay, I think that is, okay, well, one more section. So it talks about defensive programming, and the input validation is part of a practice of defensive programming. Through thorough input validation anticipates both obvious and unobvious errors. Okay, so basically we read a string, we determine whether the string can be converted to a desired type. If the string can be converted, convert it to and to continue processing. Otherwise, display an error message and attempt to. So again, we can go in and say, hey, we're going to try to make sure we look in our crystal ball, and we're going to try to make sure that we have everything covered so that whatever the user types in, we can deal with it. The last thing we ever want our program to do is to just blow up and give this user a system error, and they can't do anything about it. That's the very last thing you ever want to do. So as a programmer, we have to anticipate. And that's usually we have test teams. And all that test teams, in my line of business, before I'd actually put a program into production, we have a test team. And these folks are vicious. They go through that program with a fine-tooth comb. Okay, every time you expect this type of data, they type something else in. They actually try to blow your program up. And if they do, they let you know about it. You fix it, or you basically put this defensive programming in to make sure that no matter what the user types in, we can deal with it, give them an error message, let them type the data in again, and then go on. Maybe there's an input file. There's a problem with the input file. Well, we have to stop the program and say, there's a problem with this record, maybe give a record number or whatever the case may be, let them know where the error happened, and basically go on from there. One of the things that we like to do is we like to put in what are called log messages. We actually write to the log file every time we go into a process. We say we've gone into this process, and then we say when we're leaving that process. And why do we do that? Well, if the program blows up, I can see if I went into a sub procedure, and I can see when I went out. If I see I went into a sub procedure and I didn't go out, I knew it blew up somewhere in that procedure. So we leave these little breadcrumbs all over the place when we write these programs, so that again, when the program does blow up, I'm going to say if it blows up, I'm going to say when the program blows up, because most of the time that's usually what happens. We can trace where we need to go to fix it. Okay, it talks about addresses. Okay, we actually pay for, the company I work for, we pay for a third-party vendor package that does nothing but validates and converts addresses into a standardized address. For example, if someone lives on 2nd Street, if they type in SECOND, well, the US database sees that as 2ND. So we actually have a program that will read that word and convert it into the standardized address, because we also have what are called GIS, Global Information Systems. We may need to map that address. And some of those GIS programs are looking for a specific standardized address. They're not looking for the word second, they're looking for the word, or the phrase 2ND. And so in order for us to map and do all these different things, we have to have a standardized address. And so we actually have programs that do that for us. Maybe somebody types in SECND. We may have a program that can kind of go, you know what, I think they were trying to type the word second. I know this zip code, I know this town, there's a word called 2nd Street in that town. I'm going to go ahead and convert it to 2ND. So there's actually some programs that have that much artificial intelligence that can actually fix those types of things as well. It talks about time measurements, talks about dates. Dates are a big one. Is there 31 days in June? I don't know. Well, we have programs that can actually do that as well. Talks about hours in a week. Maybe somebody tries to put in that they worked 100 hours this week. Well, how many hours are in a week, and how many hours could a person actually work? If you work 10 hours a day, let's say you work 12 hours a day times 7, what is that? 84 hours. That's quite a lot of hours to work. That's possible. But 100 hours, that's probably a little more than what we would have probably allowed in any company. So So we probably have some type of validation check for that as well. So anyways, validation checks, very important. A very important piece of programming. I've kind of said this tongue-in-cheek. You may have heard me say this before, but I've said the stupidest people on the face of the earth are users. Why? Because when I expect them to type in numeric data, they type in something else. I expect them to type in a string formatted input, and they type something else. They're always going to type in something more than basically what you expected. So anyways, this is chapter 7, very short chapter, very easy chapter. Again, I've given you some extra time here to basically work on your midterm project. So we will see you next week.